Chapter 6 Integers. Introduction. Sunita's mother has 8 bananas. Sunita has to go for a picnic with her friends. She wants to carry 10 bananas with her. Can her mother give 10 bananas to her? She does not have enough, so she borrows 2 bananas from her neighbor to be returned later. After giving 10 bananas to Sunita, how many bananas are left with her mother? She has no banana with her, but has to return 2 to her neighbor. So when she gets some more bananas, say 6, she will return 2 and be left with 4 only. Ronald goes to the market to purchase a pen. He has only rupees 12 with him, but the pen costs rupees 15. The shopkeeper writes rupees 3 as due amount from him. He writes rupees 3 in his diary to remember Ronald's debit. But how would he remember whether rupees 3 has to be given or has to be taken from Ronald? Can he express this debit by some color or sign? Ruchika and Salma are playing a game using a number strip which is marked from 0 to 25 at equal intervals. To begin with, both of them placed a colored token at the 0 mark. 2 colored dice are placed in a bag and are taken out by them one by one. If the die is red in color, the token is moved forward as per the number shown on throwing this die. If it is blue, the token is moved backward as per the number shown when this die is thrown. The dice are put back into the bag after each move so that both of them have equal chance of getting either die. The one who reaches the 25th mark first is the winner. They play the game. Ruchika gets the red die and gets 4 on the die after throwing it. She thus moves the token to mark 4 on the strip. Salma also happens to take out the red die and wins 3 points and thus moves her token to number 3. In the second attempt, Ruchika secures 3 points with the red die and Salma gets 4 points but with the blue die. Where do you think should both of them place their tokens after the second attempt? Ruchika moves forward and reaches 4 plus 3, that is, the 7th mark, whereas Salma placed her token at 0 position. But Ruchika objected, saying she should be behind 0. Salma agreed, but there is nothing behind 0. What can they do? Salma and Ruchika then extended the strip on the other side. They used a blue strip on the other side. Now Salma suggested that she is 1 mark behind 0, so it can be marked as blue 1. If the token is at blue 1, then the position behind blue 1 is blue 2. Similarly, blue 3 is behind blue 2. In this way, they decided to move backward. Another day, while playing, they could not find blue paper. So Ruchika said, "Let us use a sign on the other side as we are moving in opposite direction." So you see, we need to use a sign going for numbers less than 0. The sign that is used is the placement of a minus sign attached to the number. This indicates that numbers with a negative sign are less than 0. These are called negative numbers. Who is where? Suppose David and Mohan have started walking from 0 position in opposite directions. Let the steps to the right of 0 be represented by plus sign and to the left of 0 be represented by minus sign. If Mohan moves 5 steps to the right of 0, it can be represented as plus 5. And if David moves 5 steps to the left of 0, it can be represented as minus 5. Now represent the following positions with plus or minus sign. A. 8 steps to the left of 0 means negative 8. B. 7 steps to the right of 0 means positive 7. C. 11 steps to the right of 0 means positive 11. D. 6 steps to the left of 0 means negative 6. Who follows me? We have seen from the previous examples that a movement to the right is made if the number by which we have to move is positive. If a movement of only 1 is made, we get the successor of the number. Write the succeeding number of the following. Succeeding number of 10 is 10 plus 1, that is equal to 11. Succeeding number of 8 is 8 plus 1, that is equal to 9. Succeeding number of minus 5 is minus 5 plus 1, that is equal to minus 4. Succeeding number of minus 3 is minus 3 plus 1, that is equal to minus 2. Succeeding number of 0 is 0 plus 1, that is equal to 1. A movement to the left is made if the number by which the token has to move is negative. If a movement of only 1 is made to the left, we get the predecessor of a number. Now write the preceding number of the following. Preceding number of 10 is 10 minus 1, that is equal to 9. Preceding number of 8 is 8 minus 1, that is equal to 7. Preceding number of minus 5 is minus 5 minus 1, that is equal to minus 6. Preceding number of minus 3 is minus 3 minus 1, that is equal to minus 4. Preceding number of 0 is 0 minus 1, that is equal to minus 1. Tag me with a sign. We have seen that some numbers carry a minus sign. For example, if we want to show Ronald's due amount to the shopkeeper, we would write it as minus 3. Following is an account of a shopkeeper which shows profit and loss from the sale of certain items. Since profit and loss are opposite situations, and if profit is represented by plus sign, loss can be represented by minus sign. Place the paper sign in the blanks of given table. Sale of mustard oil, we get a profit of rupees 150. So we write positive 150 in the blank. Similarly, for rice, we write negative 250. Black pepper, write positive 225. For wheat, write positive 200. And for groundnut oil, write negative 330. Some other situations where we may use these signs are: the height of a place above sea level is denoted by a positive number. Height becomes lesser and lesser as we go lower and lower. Thus, below the surface of the sea level, we can denote the height by a negative number. If earnings are represented by plus sign, then the spending may be shown by a minus sign. Similarly, temperature above 0 degrees Celsius is denoted by a positive sign, and temperature below 0 degrees Celsius is denoted by minus sign. For example, the temperature of a place 10 degrees below 0 degrees Celsius is written as minus 10 degrees Celsius. Integers. The first numbers to be discovered were natural numbers, that is, 1, 2, 3, 4, and so on. If we include 0 to the collection of natural numbers, we get a new collection of numbers known as whole numbers, that is, 0, 1, 2, 3, 4, and so on. You have studied these numbers in the earlier chapter. Now we find that there are negative numbers too. If we put the whole numbers and the negative numbers together, the new collection of numbers is known as integers. In this collection, 1, 2, 3, 4, and so on are said to be positive integers, and -1, -2, -3, -4, and so on are said to be negative integers. Let us understand this by the following figures. The collection of figures can be understood by the following diagram, in which all the earlier collections are included. Representation of integers on a number line. Draw a line and mark some points at equal distance on it as shown in the figure. Mark a point as 0 on it. Points to the right of 0 are positive integers and are marked as +1, +2, +3, etc., or simply 1, 2, 3, and so on. Points to the left of 0 are negative integers and are marked -1, -2, -3, etc. In order to mark -6 on this line, we move 6 points to the left of 0. In order to mark +2 on this number line, we move 2 points to the right of 0. Ordering of integers. Raman and Imran live in a village where there is a step well. There are in all 25 steps down to the bottom of the well. One day, Raman and Imran went to the well and counted 8 steps down to water level. They decided to see how much water could come in the well during rains. They marked 0 at the existing level of water and marked 1, 2, 3, 4, and so on above that level for each step. After the rains, they noted that the water level rose up to the 6th step. After a few months, they noticed that the water level had fallen 3 steps below the 0 mark. Now they started thinking about marking the steps to note the fall of water level. Can you help them? Suddenly, Raman remembered that at one big dam, he saw numbers marked even below 0. Imran pointed out that there should be some way to distinguish between the numbers which are above 0 and below 0. Then Raman recalled that the numbers which are below 0 had minus sign in front of them. So they marked one step below 0 as -1 and 2 steps below 0 as -2 and so on. So the water level is now at -3, that is 3 steps below 0. After that, due to further use, the water level went down by 1 step and it was at -4. You can see that -4 is less than -3. Fill in the boxes using greater than or less than signs. 1. 0 is greater than -1. 2. -100 is greater than -101. 3. -50 is greater than -70. 4. 50 is greater than -51. 5. -53 is less than -5. 6. -7 is less than 1. Let us once again observe the integers which are represented on the number line. We know that 7 is greater than 4, and from the number line shown above, we observe that 7 is to the right of 4. Similarly, 4 is greater than 0, and 4 is to the right of 0. Now, since 0 is to the right of -3, so 0 is greater than -3. Again, -3 is to the right of -8, so -3 is greater than -8. Thus, we see that on a number line, the number increases as we move to the right and decreases as we move to the left. Therefore, -3 is less than -2, -2 is less than -1, -1 is less than 0, 0 is less than 1, 1 is less than 2, 2 is less than 3, and so on. Hence, the collection of integers can be written as -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5, and so on. Compare the following pairs of numbers using greater than or less than sign. 1. 0 is greater than -8. 2. -1 is greater than -15. 3. 5 is greater than -5. 4. 11 is less than 15. 5. 0 is less than 6. 6. -20 is less than 2. Remember, A. Every positive integer is larger than every negative integer. B. 0 is less than every positive integer. C. 0 is larger than every negative integer. D. 0 is neither a negative integer nor a positive integer. E. Farther a number from 0 on the right, larger is its value. F. Farther a number from 0 on the left, smaller is its value. Example: by looking at the number line, answer the following questions. Which integers lie between -8 and -2? Which is the largest integer and the smallest integer among them? Solution: integers between -8 and -2 are -7, -6, -5, -4, -3. The integer -3 is the largest and -7 is the smallest. If I'm not at 0, what happens when I move? Let us consider the earlier game being played by Salma and Ruchika. Suppose Ruchika's token is at 2. At the next turn, she gets a red die, which, after throwing, gives a number 3. It means she will move 3 places to the right of 2. Thus, she comes to 5. If, on the other hand, Salma was at 1 and had drawn a blue die, which gave her the number 3, then it means that she will move to the left by 3 places and stand at -2. Example: by looking at the number line, answer the following question. A. One button is kept at -3. In which direction and how many steps should we move it to reach at -9? Solution: A. We have to move 6 steps to the left of -3. B. Which number will we reach if we move 4 steps to the right of -6? Solution: we reach -2 when we move 4 steps to the right of -6. Example: the adjacent figure is a vertical number line representing integers. Observe it and locate the following points. A. If point D is at +8, then which point is -8? Answer: -8 means 8 moves lower side of 0 and this point is F. So, F represents -8. B. Is point G a negative integer or a positive integer? Answer: G is 6 moves lower side of 0 means -6. So, G is a negative integer. C. Write integers for points B and E. Answer: B is 4 moves upper side of 0 means +4. So B represents +4. E is 10 moves lower side of 0. It means -10. So E represents -10. D. Which point marked on this number line has the least value? Answer: E has the last point of the lower side of given number line and it represents the value of -10. So, E has the least value of -10. E. Arrange all the points in decreasing order of value. Answer. Decreasing order of all the points are D is greater than C, which is greater than B, which is greater than A, which is greater than 0, which is greater than H, which is greater than G, which is greater than F, which is greater than E. That is, 8 is greater than 5, which is greater than 4, which is greater than 2, which is greater than 0, that is greater than -2, which is greater than -6, which is greater than -8, and that is greater than -10. Example A. Write 4 negative integers greater than -20. Solution. 4 negative integers greater than -20 are -19, -18, -17, -16. B. Write 4 integers less than -10. Solution. 4 negative integers less than -10 are -11, -12, -13, -14. Example. For the following statements, write true or false. If the statement is false, correct the statement. Solution. A. -8 is to the right of -10 on a number line. B. -100 is to the right of -50 on a number line. C. The smallest negative integer is -1. D. -26 is greater than -25. Statement A is true. Statement B is false. Correction. -100 is to the left of -50 on a number line. Statement C is false. Correction. There is no smallest negative integer. Statement D is false. Correction. -26 is smaller than -25. Example. Draw a number line and answer the following. A. Which number will we reach if we move 4 numbers to the right of -2? Solution. A. To move 4 numbers to the right side of -2, that is, -1, 0, 1, and 2. Thus, we move 4 numbers to the right side of -2 and we reach 2. B. Which number will we reach if we move 5 numbers to the left of 1? Solution. Moving 5 numbers to the left side of 1, that is 0, -1, -2, -3, and -4. Thus, we move 5 numbers to the left side of 1 and we reach -4. C. If we are at -8 on the number line, in which direction should we move to reach -13? Solution. From -8, if we want to reach to -13, we move 5 numbers to the left side of -8, that is, -9, -10, -11, -12, and -13. Thus, we will move 5 numbers on the left side of -8 to reach -13. D. If we are at -6 on the number line, in which direction should we move to reach -1? Solution. From -6 on the number line, if we have to reach to -1, we should move 5 numbers to the right side of -6, that is, -5, -4, -3, -2, and -1. Thus, we will move 5 numbers to the right side of -6 to reach -1. Addition of integers. Going up and down. In Mohan's house, there are stairs for going up to the terrace and for going down to the go-down. Let us consider the number of stairs going up to the terrace as positive integer, the number of stairs going down to the go-down as negative integer, and the number representing ground level as 0. Do the following and write down the answer as integer. A. Go 6 steps up from the ground floor. It represents +6. B. Go 4 steps down from the ground floor. It represents -4. C. Go 5 steps up from the ground floor and then go 3 steps up further from there. It represents +5 plus +3, that is equal to +8. D. Go 6 steps down from the ground floor and then go down further 2 steps. It represents -6 plus -2, that is equal to -8. E. Go down 5 steps from the ground floor and then move up 12 steps from there. It represents -5 plus +12, that is equal to +7. F. Go 8 steps down from the ground floor and then go up 5 steps from there. It represents -8 plus +5, that is equal to -3. G. Go 7 steps up from the ground floor and then 10 steps down from there. It represents +7 plus -10, that is equal to -3. A game. Take a number strip marked with integers from +25 to -25. Take 2 dice, one marked 1 to 6 and the other marked with 3 plus signs and 3 minus signs. Players will keep different colored buttons or plastic counters at the 0 position on the number strip. In each throw, the player has to see what she has obtained on the 2 dice. If the first die shows 3 and the second die shows minus sign, she has -3. If the first die shows 5 and the second die shows plus sign, then she has +5. Whenever a player gets the plus sign, she has to move in the forward direction, that is, towards +25. And if she gets minus sign, then she has to move in the backward direction, that is, towards -25. Each player will throw both dice simultaneously. A player whose counter touches -25 is out of the game, and the one whose counter touches +25 first wins the game. You can play the same game with 12 cards marked with +1, +2, +3, +4, +5 and +6 and -1, -2, and so on and so forth till -6. Shuffle the cards after every attempt. Kamla, Reshma and Meenu are playing this game. Kamla got +3, +2, +6 in 3 successive attempts. She kept her counter at the mark +11. Reshma got -5, +3, +1. She kept her counter at -1. Meenu got +4, -3, -2 in 3 successive attempts. At which position will her counter be? At -1 or at +1? It is on -1. Second game. Take 2 different colored buttons like white and black. Let us denote one white button by +1 and one black button by -1. A pair of one white button, that is +1, and one black button, that is -1, will denote 0. That is 1 plus -1, that is equal to 0. In the following table, integers are shown with the help of colored buttons. 5 white buttons shown here, so we represent +5. 3 black buttons shown here, so we represent -3. 1 white button and 1 black button shown here, it represents +1 plus -1, that is equal to 0. Let us perform additions with the help of the colored buttons. Observe the following table and complete it. 3 white buttons plus 2 white buttons is equal to 5 white buttons. It represents as +3 plus +2, that is equal to +5. 2 black buttons plus 1 black button is equal to 3 black buttons. It represents as -2 plus -1, that is equal to -3. 4 white buttons plus 1 white button is equal to 5 white buttons. It represents as +4 plus +1, that is equal to +5. 4 black buttons plus 2 black buttons is equal to 6 black buttons. It represents as -4 plus -2, that is equal to -6. You add when you have 2 positive integers like +3 plus +2, that is equal to +5, that is 3 plus 2. You also add when you have 2 negative integers, but the answer will take a minus sign like -2 plus -1, that is equal to -2 plus 1, which is equal to -3. Now add one positive integer with one negative integer with the help of these buttons. Remove buttons in pairs, that is, a white button with a black button, since +1 plus -1 is equal to 0. Check the remaining buttons. A. -4 plus +3 is equal to -1 plus -3 plus +3, that is equal to -1 plus 0, which is equal to -1. B. +4 plus -3, that is equal to +1 plus +3 plus -3, which is equal to +1 plus 0, that is equal to +1. You can see that the answer of 4 minus 3 is 1 and minus 4 plus 3 is minus 1. So, when you have one positive and one negative integer, you must subtract, but the answer will take the sign of the bigger integer. Ignoring the signs of the numbers, decide which is bigger. C. Plus 5 plus minus 8 is equal to plus 5 plus minus 5 plus minus 3. That is equal to 0 plus minus 3, which is equal to minus 3. D. Plus 6 plus minus 4 is equal to plus 2 plus 4 plus minus 4. That is equal to plus 2 plus 0, which is equal to plus 2. Addition of integers on a number line. It is not always easy to add integers using colored buttons. Shall we use number line for additions? 1. Let us add 3 and 5 on a number line. On the number line, we first move 3 steps to the right from 0, reaching 3. Then we move 5 steps to the right of 3 and reach 8. Thus, we get 3 plus 5 is equal to 8. 2. Let us add minus 3 and minus 5 on the number line. On the number line, we first move 3 steps to the left of 0, reaching minus 3. Then we move 5 steps to the left of minus 3 and reach minus 8. Thus, minus 3 plus minus 5 is equal to minus 8. We observe that you add when you have 2 positive integers. You also add when you have 2 negative integers. 3. Suppose we wish to find the sum of plus 5 and minus 3 on the number line. First, we move to the right of 0 by 5 steps, reaching 5. Then we move 3 steps to the left of 5, reaching 2. Thus, plus 5 plus minus 3 is equal to 2. 4. Similarly, let us find the sum of minus 5 and plus 3 on the number line. First, we move 5 steps to the left of 0, reaching minus 5, and then from this point, we move 3 steps to the right. We reach the point minus 2. Thus, minus 5 plus 3 is equal to minus 2. When a positive integer is added to an integer, the resulting integer becomes greater than the given integer. When a negative integer is added to an integer, the resulting integer becomes less than the given integer. Let us add 3 and minus 3. We first move from 0 to plus 3, and then from plus 3, we move 3 points to the left. Where do we reach ultimately? From the figure, 3 plus minus 3 is equal to 0. Similarly, if we add 2 and minus 2, we obtain the sum as 0. Numbers such as 3 and minus 3, 2 and minus 2, when added to each other, give the sum 0. They are called additive inverse of each other. What is the additive inverse of 6? What is the additive inverse of minus 7? The additive inverse of 6 is minus 6 because 6 minus 6 is equal to 0. Similarly, the additive inverse of minus 7 is 7 because minus 7 plus 7 is equal to 0. Example: using the number line, write the integer which is a. 4 more than minus 1, b. 5 less than 3. Solution: A. We want to know the integer which is 4 more than minus 1. So, we start from minus 1 and proceed 4 steps to the right of minus 1 to reach 3. Therefore, 4 more than minus 1 is 3. B. We want to know an integer which is 5 less than 3. So, we start from 3 and move to the left by 5 steps and obtain minus 2. Therefore, 5 less than 3 is minus 2. Example: find the sum of minus 9 plus 4 plus minus 6 plus 3. Solution: we can rearrange the numbers so that the positive integers and the negative integers are grouped together. We have minus 9 plus 4 plus minus 6 plus 3. That is equal to minus 9 plus minus 6 plus 4 plus 3, which is equal to minus 15 plus 7, and that is equal to minus 8. Example: find the value of 30 plus minus 23 plus minus 63 plus 55. Solution: 30 plus 55 plus minus 23 plus minus 63 is equal to 85 plus minus 86, that is equal to minus 1. Example: find the sum of minus 10, 92, 84 and minus 15. Solution: minus 10 plus 92 plus 84 plus minus 15 is equal to minus 10 plus minus 15 plus 92 plus 84 is equal to minus 25 plus 176, that is equal to 151. Example: use number line and add the following integers. Solution: A. 5 plus minus 11. We want to know the integer which is 5 plus minus 11. So, we start from 5 and proceed 11 steps to the left of 5 to reach minus 6. Therefore, 5 plus minus 11 is equal to minus 6. B. Minus 1 plus minus 7. We want to know the integer which is minus 1 plus minus 7. So, we start from minus 1 and proceed 7 steps to the left of minus 1 to reach minus 8. Therefore, minus 1 plus minus 7 is equal to minus 8. C. Minus 5 plus 10. We want to know the integer which is minus 5 plus 10. So, we start from minus 5 and proceed 10 steps to the right of minus 5 to reach 5. Therefore, minus 5 plus 10 is equal to 5. D. Minus 2 plus 8 plus minus 4. We want to know the integer which is minus 2 plus 8 plus minus 4. So, we start from minus 2 and proceed 8 steps to the right of minus 2 to reach plus 6. Now, we start from plus 6 and proceed 4 steps to the left of plus 6 to reach plus 2. Therefore, minus 2 plus 8 plus minus 4 is equal to 2. Example. Add without using number line. Solution. 1 minus 250 plus 150. This is equal to minus 250 plus 150, and that is equal to minus 100. 2 minus 380 plus minus 270. This is equal to minus 380 minus 270, and that is equal to minus 650. 3 minus 50 plus minus 200 plus 300. This is equal to minus 50 minus 200 plus 300, which is equal to minus 250 plus 300, and that is equal to 50. 4. 37 plus minus 2 plus minus 65 plus minus 8. This is equal to 37 minus 2 minus 65 minus 8, which is equal to 37 minus 75, and that is equal to minus 38. Subtraction of integers with the help of a number line. We have added positive integers on a number line. For example, consider 6 plus 2. We start from 6 and go 2 steps to the right side. We reach at 8. So, 6 plus 2 is equal to 8. We also saw that to add 6 and minus 2 on a number line, we can start from 6 and then move 2 steps to the left of 6. We reach at 4. So, we have 6 plus minus 2 is equal to 4. Thus, we find that to add a positive integer, we move towards the right of a number line, and for adding a negative integer, we move towards left. We have also seen that while using a number line for whole numbers, for subtracting 2 from 6, we would move towards the left. That is, 6 minus 2 is equal to 4. What would we do for 6 minus minus 2? Would we move towards the left on the number line or towards the right? If we move to the left, then we reach 4. Then we have to say 6 minus minus 2 is equal to 4. This is not true because we know 6 minus 2 is equal to 4, and 6 minus 2 is not equal to 6 minus minus 2. So we have to move towards the right, that is, 6 minus minus 2 is equal to 8. This also means that when we subtract a negative integer, we get a greater integer. Consider it in another way. We know that the additive inverse of minus 2 is 2. Thus, it appears that adding the additive inverse of minus 2 to 6 is the same as subtracting minus 2 from 6. We write 6 minus minus 2 is equal to 6 plus 2. Let us now find the value of minus 5 minus minus 4 using a number line. We can say that this is the same as minus 5 plus 4, as the additive inverse of minus 4 is 4. We move 4 steps to the right on the number line starting from minus 5. We reach at minus 1. That is, minus 5 plus 4 is equal to minus 1. Thus, minus 5 minus minus 4 is equal to minus 1. Example. Find the value of minus 8 minus minus 10 using number line. Solution. Minus 8 minus minus 10 is equal to minus 8 plus 10, as the additive inverse of minus 10 is 10. On the number line, from minus 8, we will move 10 steps towards right. We reach at 2. Thus, minus 8 minus minus 10 is equal to 2. Hence, to subtract an integer from another integer, it is enough to add the additive inverse of the integer that is being subtracted to the other integer. Example. Subtract minus 4 from minus 10. Solution. Minus 10 minus minus 4 is equal to minus 10 plus 4, which is the additive inverse of minus 4. So that is equal to minus 10 plus 4, which is equal to minus 6. Example. Subtract plus 3 from minus 3. Solution. Minus 3 minus plus 3 is equal to minus 3 plus minus 3, since it is the additive inverse of plus 3. So that is equal to minus 3 plus minus 3, which is equal to minus 6. Example. Fill in the blanks with greater than, less than, or equal to sign. Solution. 1. Minus 3 plus minus 6 dash minus 3 minus minus 6. Therefore, minus 9 is less than 3. 2. Minus 21 minus minus 10 dash minus 31 plus minus 11. Therefore, minus 11 is greater than minus 42. 3. 45 minus minus 11 dash 57 plus minus 4. Therefore, 56 is greater than 53. 4. Minus 25 minus minus 42 dash minus 42 minus minus 25. Therefore, 17 is greater than minus 17. Example. Fill in the blanks. Solution. 1. Minus 8 plus dash is equal to 0. Minus 8 plus 8 is equal to 0. 2. 13 plus dash is equal to 0. 13 plus minus 13 is equal to 0. 3. 12 plus minus 12 is equal to dash. 12 plus minus 12 is equal to 0. 4. Minus 4 plus dash is equal to minus 12. Minus 4 plus minus 8 is equal to minus 12. 5 dash minus 15 is equal to minus 10. 5 minus 15 is equal to minus 10. Example: find. Solution: 1. Minus 7 minus 8 minus minus 25. This is equal to minus 7 minus 8 plus 25, which is equal to minus 15 plus 25, that is equal to 10. 2. Minus 13 plus 32 minus 8 minus 1. This is equal to minus 13 plus 32 minus 9. That is equal to minus 13 plus 23, which is equal to 10. 3. Minus 7 plus minus 8 plus minus 90. This is equal to minus 7 minus 8 minus 90, which is equal to minus 105. 4. 50 minus minus 40 minus minus 2. This is equal to 50 plus 40 plus 2, that is equal to 92. What have we discussed? 1. We have seen that there are times when we need to use numbers with a negative sign. This is when we want to go below 0 on the number line. These are called negative numbers. Some examples of their use can be in temperature scale, water level in the lake or river, level of oil in tank, etc. They are also used to denote debit account or outstanding dues. 2. The collection of numbers minus 4, minus 3, minus 2, minus 1, 0, 1, 2, 3, 4, and so on is called integers. So, minus 1, minus 2, minus 3, minus 4, and so on, called negative numbers, are negative integers, and 1, 2, 3, 4, and so on, called positive numbers, are the positive integers. 3. We have also seen how one more than the given number gives a successor, and one less than the given number gives its predecessor. 4. We observed that A. When we have the same sign, add and put the same sign. 1. When two positive integers are added, we get a positive integer. Example: plus 3 plus plus 2 is equal to plus 5. 2. When two negative integers are added, we get a negative integer. Example: minus 2 plus minus 1 is equal to minus 3. B. When one positive and one negative integers are added, we subtract them as whole numbers by considering the numbers without their sign, and then we put the sign of the bigger number with the subtraction obtained. The bigger integer is decided by ignoring the signs of the integers. Example: plus 4 plus minus 3 is equal to plus 1 and minus 4 plus 3. That is equal to minus 1. C. The subtraction of an integer is the same as the addition of its additive inverse. 5. We have shown how addition and subtraction of integers can also be shown on a number line.